Okay, so continuing on our discussion from chapter 3, we had built up in the previous section our models of constraints, right? The production possibility frontier and the consumer budget constraint, telling us what are the maximum quantities that a consumer can purchase and a producer can produce. Now, what we need to do is add a model of relative preferences, right, to answer the question, finally, where along those constraints are going to be the optimal combinations, right? So that's the setup for our basic demand curve model. Now, as always, we want to start with being on the same page, right? So talking about basic definitions here, it's going to be important. In the context of economics, when we talk about demand, we're specifically talking about the mathematical relationship between price and quantity demanded. Normally, you think of demand as just saying, well, how many of something do I want? What do I demand? Well, here it's, again, an entire mathematical relationship. And the variables that are being related are the price per unit and the quantity consumed or the quantity demanded. So, how do those relate to each other in isolation? So, another phrase that we're going to come upon a lot is holding all other factors constant. If the price of something changes, how do I react? If I buy one more unit, how does my price that I'm willing to pay change? So when we talk about holding all other things constant, we use that nifty little Latin phrase, ceteris paribus. Okay? So in isolation, how do those two things relate to one another? Okay? So we'll see this in equation form, most of the time in XY graphical form, uh, and also in tabular form. So what we call a demand schedule, just looking at the specific combinations of these variables that as they relate to each other. We'll see plenty of examples of all of those things. So continuing on with that theme of being precise with our definitions and interpretations, we all know what a price is, right? So how many dollars do you have to sacrifice to obtain one unit of a good or service? But there's a little bit more to it in the context of the demand model, right? So from the point of view of the consumer, and all of this more or less is from the point of view of the consumer, uh, price we'll say represents two different things. First, yes, it is the market price. So what's on the price tag? How many dollars do I have to give up to get that product? And that'll be the revenue earned per unit to the seller as well. But it's also going to represent this other very important concept of our maximum willingness to pay. So if I look at a product, a cup of coffee, a slice of pizza, an automobile, a house, a year's worth of education, whatever it is, the assumption is that me, the individual consumer, can calculate how much it's going to be worth to me. What's the most number of dollars I'd be willing to sacrifice for that product? So that's this WTP, willingness to pay, corresponding to the basic idea of the marginal utility or the marginal benefit expected to be extracted from consuming that unit. What's it worth to the consumer? On the other side of the equation, we're relating price to quantity. Again, we'll be precise with our terminology and our notation. So QD, quantity demanded, the number of units desired to be consumed per period of time. How many cups of coffee do I want per day, per week, per month at a specific price? Okay. And again, think about the consumer budget constraint model from chapter 2. That also gave us a relationship between quantity and price, right? In the sense that the maximum quantity that we'd be able to consume, the intercepts on that budget constraint line, were determined both by our available budget, our income, and the prices that we have to pay. And we also saw, again, the role of cost and price when we move along that budget line to increase consumption of one good, that extra dollar value paid represents some number of units sacrificed in the alternative sector. So, in a sense, All of these issues are familiar. We are just rearranging them specifically to relate price to quantity instead of quantity to quantity across two different goods, like we saw on the budget constraint line. So when we are thinking about putting ourselves in the shoes of the consumer, calculating our willingness to pay for one more unit of a good or service, all of these things are being taken into consideration. Budget, prices of related goods, opportunity costs. Again, we're putting a lot of pressure on the consumer to be able to make these instantaneous calculations, but we're assuming again that the average consumer acts as if they are making these judgments. So, if our concern is how price and quantity demanded relate to each other, we have a very specific expectation, and we're so confident about it that we will call it the law. The law of demand, again, term that gets thrown around a lot, law of supply and demand, law of demand, has a very specific meaning in terms of these variables. And it's also very simple. The law of demand just states that there will be an inverse or negative relationship between price, market price, willingness to pay, and quantity demanded, number of units desired to be consumed per period of time, holding all else constant. They will go in opposite directions. Again, for the most part, this is pretty straightforward and we experience it every day. If you tell me you're going to charge me a higher price for something, I'm probably going to react by wanting to buy less of it. I'm going to substitute towards something else. Quantity demand goes down. Likewise, the other causal direction that we can explain for this law of demand, as price goes down, quantity goes up. Right? Again, pretty self-explanatory. We want to be specific. It's going to be important for us to be able to break down for different types of goods and services exactly why and how strong this relationship is going to be. But as far as our definitions are concerned, have that one down. Law of demand, inverse or negative relationship between price and quantity, holding all other things constant, ceteris paribus. So why are we so confident that this is going to occur? It would be good if you could cite each of these three different reasons for this law of demand result. Reason number one, the old issue of diminishing marginal utility. Right? The more of any activity you engage in, the less additional gain, additional benefit, additional happiness you receive. And since willingness to pay is exactly a measure of expected happiness, expected gain per unit consumed, this just tells us the more of something you consume, the less benefit you receive, the less you'll be willing to pay for it. So one goes up, the other goes down. So again, note a couple things. This is once again citing that ceteris paribus condition, right? So if the only thing that changes is you are eating additional pieces of pizza, each additional piece of pizza gives you less additional happiness. You're willing to pay less and less for each additional unit. And there is the law of demand result, right? Quantity goes up, willingness to pay, therefore price, the dollar value assigned to each unit is coming down. So that's reason number one. We can be pretty confident on that. The other thing to point out is we also have this little addendum to the definition of this law of diminishing marginal utility, that it occurs past a certain point, right? It's not guaranteed that the second piece of pizza gives you less benefit than the first. It might very well be increasing for a little while, but eventually, no matter what the activity it is, how much you enjoy it, eventually you're going to get less and less additional benefit. So this will kick in and have this inverse relationship effect. As mentioned, the second, again, fairly obvious reason why this law of demand is going to persist is the substitution effect. Right? Like I said, if you tell me that the price of a product is going to go up, as long as I have an alternative, a substitute to switch to, I can go ahead and consume less of that more expensive good. So the substitution effect tells us as the price of a product goes up, so now interpreted as market price rather than willingness to pay, I will consume less of that good and move towards an available alternative. We can really think of this as a change in the slope of that budget constraint, right? Slope represents those opportunity costs. So if the price of, for example, good X goes up, it becomes relatively more expensive. You have to give up more to receive that one extra unit of X. So you're naturally going to substitute towards the alternative Y. Now, in chapter 5, we're going to focus in on the concept of elasticity, which will be an exact measure of how much flexibility you have. And that's going to be determined by how many reasonable substitutes there are for a given product. Our assumption for now is virtually every good or service out there has some substitute, some alternative from the point of view of consumers, a good that gives you similar types, plays a similar role in your utility or your satisfaction. So once that price of one good goes up, its relative price goes up, you're going to buy more of the cheaper alternative and less of the more expensive. And again, for our limited exercise right here, this is what we want to establish, right? The inverse relationship. Market price goes up, quantity demand goes down, as long as we've got this outlet, as long as we've got somewhere else to get that utility, that alternative or substitute. So let's just take a quick look back at that budget constraint view of this substitution effect, right? So just to recall, right, that budget constraint relates the consumption of one good, good Y here on the vertical axis, to the quantity consumed of an alternative good, good X here. So imagine that we have an initial point as this affordable combination of X and Y. And then, for some unknown reason, we'll get to why this might happen in a very near future episode here. There's an increase in the price of good X. Again, we take that to mean an increase in the price of X relative to Y. So that's going to cause a steepening effect of that budget line. So what does that mean? We're now capable of consuming more Y and less X. And the substitution effect makes a prediction like this, right? That we're going to move up and to the left, which of course means less X and more Y. So price of X went up, consumption of good X went down. That's the law of demand substitution effect prediction. So it's nice to have in the back of your mind that pivot effect on the budget line. Change in relative prices, change in opportunity cost. Okay. So I did mention there were 3 reasons why we're so confident that we're going to see this law of demand inverse relationship. And the third also comes directly from the logic of the budget constraint model. I kind of wish there was a better name for this. The so-called income effect sounds like we're talking about a change in income affecting our consumption. That is a real thing, of course, and we'll talk about that when we get to those determinants of demand. But here we're talking about, again, still reacting to a change in price. But what we're saying is when the price of one good goes up, then every unit that we consume eats up a bigger portion of your budget. The real purchasing power of your budget, of your income, falls. Higher prices means we can afford less stuff, and therefore we're going to consume less, and therefore price goes up, quantity goes down. Inverse relationship, law of demand. So how this relates back to the budget line, the budget constraint, right, is in reality, when the price of one good goes up, it's not just changing the slope, it's pivoting the whole thing inward, right? So the area representing affordable combinations gets smaller, and we have to cut back on consumption. Now, we'll talk about this when we get to elasticity in chapter 5 as well. But it should make sense that this effect might be stronger for different types of goods or services, right? So if the price of salt went up by 10%, right? That's such a small part of the average household budget. It's really not going to eat have an appreciable effect of eating away the purchasing power of your income. But if your tuition goes up by 10%, if your rent goes up by 10%, then you're going to have to cut back on a lot of different things. There's going to be a real purchasing power effect. But even without substitution effects, this income effect is going to lead to where we knew this was going, the inverse law of demand relationship. Right? Price of good goes up, purchasing power of your budget comes down, you can afford less, you buy less, quantity demanded goes down. So, with all of that said, it's useful, I think, at this point to just to put some example numbers to a individual consumer demand curve. And let's just go with a classic where say we're relating quantity demanded of coffee, so cups per week versus the price per cup. And just imagine that these numbers represent, and they're not, far off probably, my personal preferences for coffee consumption. And it's useful to think of each of these combinations, these price quantity combinations, as, an if-then statement, right? If the price was $1, I would be willing to buy 10 cups of coffee per week. On down the line, if the price was $5 per cup, I would only be willing to consume 2 units. So that's the first kind of interpretation that we would apply to the numbers on the table, as well as the visualization, which plots out each of those combinations. So just to pick one of those, if the price was $4, so we were here, the position of the demand curve, the values on the table tell us the maximum quantity that I'd be willing to purchase would be 4 units per week, 4 cups of coffee per week. Left, down. So that horizontal position of the demand curve gives us that maximum quantity. It's also important to have the story flipping the if-then statement, right? Each of these quantities has a maximum dollar value attached to it. That's that willingness to pay interpretation. So from that same point, if you're asking me, how do I feel about that 4th cup of coffee per week? I would tell you, I would get $4 worth of satisfaction out of that 4th cup of coffee. That's the most I'd be willing to pay for it. And that's the vertical interpretation of the demand curve. The height of the demand curve gives us exactly that dollar value benefit, that dollar value willingness to pay associated with each potential quantity consumed. Right? So up and over gives us, if I consume this much, this would be my willingness to pay. So once we've got that story that we can tell for any combination of price and quantity, any point along that demand curve, it naturally follows that we can now use that demand curve to make predictions and interpret a movement from one point to another. So when we talk about a movement along a demand curve, we're talking about a change in quantity reacting to a change in price. So if we start from that point we were just looking at, $4 per cup and a quantity of 4, call that our point A here. Moving to point B is going to have 2 interpretations, right? So interpret what we'll call interpretation 1. If the price falls from 4 to 2, I would react by increasing my consumption from 4 cups to 8 cups. I would move down and to the right along that curve. And where did that number come from? How do I land on 8 when the price is 2? How do I know how much more I'm going to be willing to consume? Well, that's the combination of diminishing marginal utility, substitution effect, and income effect. And again, I could ask you a question like this, and you would have a pretty ready answer, right? So if the price of coffee fell from $4 to $2, how would you react? And you'd say, well, I'd probably buy 2 more cups a week, or in my case, 4 more cups a week. And it's just kind of a gut reaction. The economist, again, has this very optimistic view of what's happening inside of our brains, right? That we're doing all of these calculations like, well, this is going to be my expected utility, and I'm taking into consideration all of the available substitutes and the real purchasing power of my budget. Dot, 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 dot. You get your calculator out, 4 more cups a week. Now, we know none of us ever actually do that, but again, on average, we act as if we do. So that all is happening in this movement from A to B in this one interpretation. The other way to think about it is the other if then statement, right? If for whatever reason I'm contemplating consuming 4 additional cups per week, well, my willingness to pay is going to fall from $4 to $2, diminishing marginal utility along the demand curve. So both are happening at the same time. Both are true interpretations, just depending on kind of which question you're asking and answering, how to phrase it. So we need to make a major adjustment at this point, right? So we've got it pretty well sorted out what's happening at the individual level, all of the psychological and expectational calculations being made to construct that demand curve. From the point of view of solving the resource allocation problem, society-wide or market-wide, as well as how a firm would use this information to solve their profit maximization problem, we can't just look at one individual consumer at a time. We need to be able to aggregate them. We need to be able to look at the entire demand for a given product across a market. So luckily, that's going to be pretty easy. We've done all the hard work already. What we need to do is construct this idea of the market demand. At every possible price, what is the summation, the aggregation of quantity demanded across all consumers in the market? Right? So that's our market demand, relating price to the sum of quantity demanded across consumers. And it might look something like this, right? So this will just be a number attached to every price level. So every price will have a different level of quantity demanded for each individual consumer. That's that superscript I, right, the index by consumer. And we add that up across the entire population of consumers that we would denote as N. So the summation of quantity demanded across all consumers at every price level will give us the sequence of values defining market demand. Probably making this more complicated than it needs to be. Just looking at a simple example, say N is equal to 3. So there's me and 2 other people, just to keep it simple, contemplating buying coffee in this little market with the numbers for the price combinations the same. So we imagine price ranges from $1 to $5 per cup. Consumer 1, we'll say that's me. We saw price started at 10. I'm sorry. At price of 1, we had quantity demanded of 10, coming down to 2 at the price of 5. Consumer 2, they're a little bit less enthusiastic about coffee. Their values are half of mine, still displaying that law of demand result, reducing quantity demanded as price goes up. And then consumer 3, slightly larger quantity demanded values, but also reducing at a clip of 2 cups for every $1 increase in price. So the market demand is simply going to be adding up all of these values, what we would call a horizontal summation. One demand curve added to the next, to the next, to the next. So these values on the right-hand side, all these summations, will be the position of the market demand curve. How many total units can I expect to sell at each given price? Now, realistically, of course, this would be thousands, tens of thousands, hundreds of thousands, millions of individuals making up a market. The concept is going to be the same. It's still going to be this idea of a horizontal summation. So adding the quantities at every price level, tracking the relationship. So the combination of the first column and the last column would be our resulting market demand curve. If we plotted those out on our little diagram, it would look something like this. So there's our total quantity demanded of 27 at the price of 1, and then the rate of decreasing quantity demanded as price increases. Most of the time when we're dealing with certainly, again, profit maximization or equilibrium levels, this is what we're going to be looking at. But it's also important to remember what's happening behind the scenes. It's all of these individual decision making for each consumer in the market. All of that's still happening, and now we're just aggregating it. So, an example from recent news. This is one of those evergreen examples. Whenever you're watching this, it's probably true. The price of eggs keeps going up, and people are reacting. So the price of eggs has soared in the past few months. Shoppers are doing double takes as a dozen eggs rings up at more than $9 at some retailers. So, of course, what does that mean? Shoppers are doing double takes. It means they're cutting back on consumption, right? So rising prices leading to lower sales. And then down on the last little paragraph here, why is this happening? The biggest factor pushing up egg prices is a wave of avian flu, began early 2022, led to the culling of millions of egg-laying hens, RIP. With demand remaining steady, that reduced supply has caused prices to rise. So that's saying quantity going down has led to prices going up, a movement up and to the left along a demand curve. Quantity down, price up. The other one is, again, the same relationship, just in the other direction. Rising prices, quantity demanded fall. Both are consistent, we would say, with a movement along a market demand curve. So we should be able to sketch that out and picture that relationship. So now that we've got the story down, what's happening at one point on an individual demand curve and how we move along it, what's happening at the market level at one point on a demand curve or a movement from one point to another. The last element is let's remove that ceteris paribus condition, right? Where we said we're just looking at how we react to prices, that relationship between price and quantity holding everything else constant. Well, of course, the real world doesn't work that way. All sorts of things are changing that affect our willingness and ability to consume. And when anything other than price influences our consumption, that's going to move that entire demand relationship. All the numbers in the column in the table are going to change. The equation is going to change. The position of the curve is going to change. So instead of a movement along that demand curve, this will be displayed and interpreted as a shift of the curve. Okay? So again, previously, looking at a movement along demand, yes, we're buying more or buying less, but because it's a reaction only to a change in price, we have to be particular with our terminology here. We would call that simply a change in quantity demanded. We're reacting to a price change, ceteris paribus, all else constant. Anything else that affects our desired consumption will be a shift in demand or a change in demand. The whole relationship is going to move. So clearly this can go in either direction. Something could cause us to buy more at all prices or less at all prices. And just like with each point on the demand curve and a movement along, there's two interpretations, two ways to think about this. So imagine we have a case of an increase in demand. Visually, the whole curve is going to be moving upwards and to the right, which is going to tell two different stories. Right? The vertical position changes and the horizontal position changes, and each of those had its own interpretation. The horizontal is telling us at every price level, there are more units demanded. Something is making this product more popular, other than it being cheaper, right? The price hasn't changed, but we want to buy more of it. The other interpretation is that vertical position, in this case, is going upwards. So something is causing there to be an increase in willingness to pay for every unit. Right? It's not that there are fewer units, so we're willing to pay more. It's every unit we're contemplating consuming, every cup of coffee, every slice of pizza, whatever it is, we value it more highly. Our willingness and ability to pay has increased. So the story would be displayed something like this, right? So now we have on the same set of axes here the again, price per cup of coffee and our little market quantity demanded. Again, just a toy little example with three individuals, but we can get the point across where we've got now two demand curves, the original being D1, something has moved us up to D2. And if we pick a point on the original curve, call it point A, $3 per cup, market quantity demanded of 17, what does it mean for us to move to a new demand curve? Well, it means two different things. Going from point A to point B, that's the willingness to pay effect, right? At the same quantity for that 17th cup of coffee, willingness to pay has risen from 3 to 5. Willingness to pay goes up by $2 for each unit. So that's the vertical position. The horizontal position, going straight across from point A to point C on the new demand curve, at the price of $3, we're willing and able to consume additional units. There's a change in quantity demanded at delta QD that, again, is now occurring at every possible price level. In this case, we're moving over 10 units. So we used to consume 17, now we want to buy 27, still for the price of $3, reacting to something other than price. And then lastly, let's bring this home. Things can go south, literally, go down. We can move in the other direction, which would be deemed a decrease in demand. And now this is going to be a shift left or downward of the position of that demand curve. And again, everything's going to have those two interpretations. So now we want to purchase less at every price level, and we're willing to pay less at every quantity level. Something has made this a less popular item. So visualization, same thing. Start at that demand curve D1, same point we started at in the previous example, point A. And if we move straight down, that vertical position is the willingness to pay. We used to be willing to pay $3 for the 17th unit. Now it's only $1. Willingness to pay has come down, and we could say that at every point. Simultaneously, we could say that at the price of $3, our quantity demanded has dropped, again, by 10 units here. Desired consumption falls at every price level. So if you're given a story that leads to one of these results, be able to draw the correct graph and vice versa. If you see a diagram like this, be able to write an interpretation, right? What is happening here, right? And there's two answers, the up, down, and the left, right interpretation. So now this raises an obvious question. Where we're heading next is, what are the factors most likely to have caused a demand curve to shift left or right? So that's our demand determinants. Then, of course, we have to ask ourselves, what is happening on the production side of the market? How does quantity supplied relate to price and cost of production? So we'll develop our supply model, and then we'll put them all together and see how a market balances those forces of consumption, production, profit maximization, and utility maximization in a market equilibrium. So that's where we're heading next. Thank you for your patience, and stay tuned for those next lessons.